Good morning, students. Welcome to the new semester first lecture. I'm Kunal Vananjay. Today, for this lecture, we are going to introduce the syllabus. In our syllabus for this semester, we have two papers. One is statistical, mathematical physics, and relativity, and next paper is modern and nuclear physics. So, for this semester, I'm taking this paper, that is modern and nuclear physics. So, paper number is 8, course code physics 202. This paper includes 45 lectures and of 50 marks. So according to the name of the paper, it includes some modern physics and some parts of nuclear physics, in which photoelectric effect and the X-ray, that is related with the modern physics, and nuclear forces and model, and the particle accelerators and detectors. This is the part of nuclear physics. So totally for this paper we have 4 chapters. So taking brief introduction of all these chapters. First chapter is photoelectric effect. We already know about this effect, that is simply the removal of electron by using the photon, that is called as the photoelectric effect. Means electrons are removed, or we can produce free electrons by using photons or light, that is called as the photoelectric effect. So in this chapter we are going to study about the photoelectric effect and the electron, that is called as the photoelectrons, which was removed or ejected by the photons. So for this, just taking introduction, in which Lennard's method to determine E by M of photoelectrons. So by using this Lennard's method, we can determine the ratio of charge to mass for the electron, that is also called as photoelectrons. As it is ejected by the photons, that electrons are called as photoelectrons. Then in the next part, we are going to discuss about Richardson and Compton experiment, that will explain what is the photoelectric effect and what actually happens with the photoelectric effect. After that, the relation between photoelectric current and the retarding potential. The photoelectric current, which depends upon the number of free photoelectrons, that is basically depends upon the retarding potential for that material. So we will discuss the relation between that photoelectric current and the retarding potential. After that, we will discuss relation between velocity of photoelectrons and the frequency of light. Then after that, photoelectric cells. So after studying the photoelectric effect, we will discuss different applications of this photoelectric effect, means which devices are working on this effect, that is photoelectric effect. So some of the elements, that is photoelectric cells, in which first one is photoemissive cell, then photovoltaic cell, photoconductive cell. So these are some of the devices or applications of this photoelectric effect. So overall this chapter includes all about the photoelectric effect. Then next chapter, X-rays. We know that X-ray is the very applicative concept in case of various fields in physics as well as the normal life. So here in that case we are going to discuss the introduction of X-ray. After that, absorption spectra of X-ray, as every light is having absorption and emission spectra. So here we are going to study about the absorption spectra of X-ray. After that, Lewis experiment, then Bragg's law. So this experiment is explaining the application of the X-rays. Then Bragg's law, which will decide the directions of the X-rays which are passing from particular materials, which is depends upon this concept of refraction. The next one, Bragg's X-ray spectrometer. So here the Bragg's X-ray spectrometer, which is useful to study the X-rays. The normal photometer, we will use different rays or different regions of the spectrum, that is UV, ultraviolet, like this. But this spectrometer is used only the X-rays, that is called as the Bragg's X-ray spectrometer. The next one, powder crystal method, then Louis method. So these are the two methods to study the X-ray diffraction, means diffraction of X-rays by the different materials, that can be studied by using these two methods. Then we will discuss X-ray spectra, then main features of continuous X-ray spectrum and characteristics of X-ray spectrum. Means overall in this chapter we are going to discuss how X-ray are producing, what are the applications of X-rays, and what is the X-ray spectrum. So this will be discussed in this chapter. Then the second part of this paper, that is the nuclear physics part, in which we are having two chapters. First chapter is nuclear forces and models, that is the third chapter, that is nuclear forces and models. So in this chapter we are going to discuss about the nuclear physics, in which basically we are discussing the nuclear forces. In the nature there are different type of forces. This is one of these forces, and which is having very much great importance in various types of energy production. So the nuclear forces are very much important, and there are different nuclear models, as there are atomic model like Bohr's atomic model, Dalton atomic model. We are having different nuclear models also there. So in this chapter we are going to discuss about nuclear forces and models, in which introduction, then binding energy, the nuclear stability and nuclear forces. So how the nucleus is stable, what are the energies required to bind that nucleus, that is called as binding energy, then how much that nucleus is stable, and what are the forces present in that nucleus, that is the nuclear forces. Then Meson theory of nuclear forces. So this theory is related with the how these nuclear forces are generated, that will be discussed by this Meson theory of nuclear forces. This is about the nuclear forces. Next part is the nuclear models. So as there are different types of atomic models, we are also having different types of nuclear models. So what are the nuclear models? First one, the liquid drop model, that considers nuclear is acting as a liquid drop. Then shell model, which considers the nucleus is nothing but made up of different layers of the materials, or it is the shell type structure. Then next one, these nuclear models will describe various concepts related with the nuclear forces, that is energy released in the fission reaction, then chain reaction, after that atom bomb, nuclear reactor. So these are the examples of this nuclear reaction, that is called as nuclear fission reaction. So atom bomb and the nuclear reactor, these are the examples of nuclear fission reaction. After that we are having nuclear fusion. This is again one of the nuclear reaction, for which the example is the source of stellar energy, means energy obtained from various stars, that is nothing but due to the nuclear fusion process. So all about the nuclear forces and model. So this is the third chapter of this paper. Then last chapter of this paper, that is the particle accelerators and detectors. So we know that for the nuclear fission reaction we requires very energetic particle, but such particles are not obtained in the natural environment. So we have to take some particles and we have to accelerate these particles. So in this chapter we have to discuss first, that is the particle accelerators, means particles are accelerated by using some arrangement, that is called as the accelerators. And after that the detectors, so various nuclear particles can be detected by some instrument, that is called as the detectors. So in this chapter we are going to discuss about particle accelerators and detectors. So what are the accelerators? So in which we are having linear accelerator, then cyclotron, then synchrocyclotron, Betatron. So up to this, these are the particle accelerators which are used to accelerate any type of particles that may be positively charged, negatively charged. Then next part is the detectors. So how you can detect various particles of the nucleus like meson, boson, like this. So to detect such a particles, we are having some nuclear detectors. So first one is ionization chamber, then proportional counter, and then last one is the Geiger-Müller counter. So these are the detectors which are used to detect the nuclear particles. So these are the four chapters for this paper, that is modern and nuclear physics. So for this paper we are having some reference books to refer. First one, Modern Physics by J.B. Rajan, then Modern Physics by R. Murugesan by Chan publication. Then next one is for the nuclear physics part. The book is Nuclear Physics by Kaplan, the Nuclear Physics by B.N. Srivastava, and last one is the Atomic and Nuclear Physics by N. Subramaniam and Brijlal. All these are the reference books which are available for this paper. So this is about the paper, that is the modern and nuclear physics for this semester. So after this, the next lecture will be the syllabus lecture, in which we will start one of the chapters from this paper. Thank you very much.